Hey, welcome to this video about equivalent ratios, aka also known as proportions. That is right. Equivalent ratios are proportions. So if you hear me saying equivalent ratios, but then you hear me say, are these proportionate? It's the same thing. So what does that mean? Well, I'm talking about when two ratios express the same relationship between numbers. They might not be equal to each other, like 1 to 2 is equal to 1 to 2, but they have the same relationship. Let me give you kind of a visual of what we're talking about today. These two dogs are proportionate. They're not the exact same thing, right? One dog is bigger than the other, but they are the same, right? They still look the same. I'll give you a couple more examples here. Here's a picture of Little Lisbon and a picture of Bigger Lisbon, right? They're both still Lisbon, but one Lisbon's bigger than the other. One picture is 2 inches by 3 inches. The other picture is 4 inches by 6 inches. These two ratios right here, the 2 to 3 and the 4 to 6 ratio, they're equivalent. We're not going to say they're equal. Well, you can say they're equal, but we most likely say that they're equivalent. Or you can say that these two pictures are proportionate with each other. They're equivalent, they're proportionate. Let me give you a non-example. Okay, this right here, yes, there are two pictures of Lisbon, but is it the same Lisbon? Not really. Like, this little Lisbon right here is not really my Lisbon. Like, her little face is too long. That just doesn't look like my regular Lisbon. So what we see is if a picture is 3 inches by 6 inches, and then we try to change it so it's 2 inches by 8 inches, it's not proportionate. These two pictures are not equivalent. They're not proportionate, which is why we have this cool little symbol right there. That is the not equal to sign. See how it's like a cool equal sign, but then it's like, nope, it's not. It's not equal to each other. So 3 to 6 is not equal to 2 to 8. Okay, now let's look at these two examples again. These two pictures are equivalent, right? These are both pictures of Lisbon. It looks like regular Lisbon, just one is bigger than the other. If one picture is 3 by 9 and the other picture is 1 by 3, well, then we can say that those two ratios are equivalent. And really all we did is we got 3 times smaller. I just divided that by 3, divided that by 3, and now I've got a picture that is 3 times smaller than the bigger picture. Okay, here's a non-example. Another example of ratios that are not proportional. Look at this fat little chubby Lisbon. That is not really what she looks like. Okay, so 3 by 9 right here is not equivalent to 4 by 3. So that's just a visual of when we're talking about are these ratios equivalent? It's are they the same measurement? Do they have the same look to them? So how do we get these equivalent ratios? Well, we either multiply the two numbers by the same thing, or we divide the two numbers by the same thing. Let me give you an example of this. So if we have the ratio 6 to 8, I can create an equivalent ratio by timesing the top and the bottom by the exact same number. So 12 to 16 is equivalent to 6 to 8. You could say it's double the amount. So if one picture was a 6 by 8 picture, the second picture was twice as big, but it still looked the exact same. So 12 to 6 is proportionate, or we could say it's equivalent to 12 to 16. So that's one example. Another thing we can do is we can take 6 to 8 and we can divide it by the same number. I'm going to divide both of these by 2. And now I have a ratio that is 3 to 4. So again, we can say that 6 to 8 is equivalent to 3 to 4. So if we have, again, a picture that's 6 by 8, and if we make it twice as small and make it so it's 3 by 4, it'll still look the exact same. It's just the size is different. So that is how we create equivalent ratios. We can often take those and put them into what's called an equivalent table. or a ratio table. But what you'll see is a table where we just take the ratios and we put the number on top, the number on bottom, and we create what's called a table. So Jessa made fruit punch by mixing 2 pints of orange juice with 5 pints of pineapple juice. To make more punch, she needs to mix orange juice and pineapple juice in the same ratio. That's really, really, really important, right? She wants her fruit punch to taste the exact same. So how can she make it taste the exact same? It's super popular, right? If she only mixes 2 pints of orange juice and 5 pints of pineapple juice, it's going to be drank by everyone really quickly. So she's got to make more, but she wants to make it taste the same. So she can't do 2 pints of orange juice and 10 pints of pineapple juice. That will not taste the same. That's going to be way too pineapple-y, isn't it? So what do you have to do? You have to do the exact same thing to both of the numbers. So if we times them both by 2, do you like my little dot for times by 2? Then we get 4 orange juice pints and 10 pineapple juice pints. That's going to taste the exact same. We're going to have twice as much because we doubled the ratio, but it's going to be equivalent. It's still going to taste the same. Same thing if we choose to times it by 3. Maybe we want to make triple the recipe. Make it 3 times as much. Well, then we'll have 6 pints of orange juice and 15 pints of pineapple juice. It'll still be equivalent because we're doing the same thing to the orange juice and the pineapple juice. We could get even bigger. We could quadruple the recipe, meaning we times the pineapple juice and the orange juice by 4. That would give us 20 pints of orange juice and 8 pints of orange juice, 20 pints of pineapple juice, and it would still taste exactly the same. This is why equivalent ratios is so, so, so important. It's keeping things the same, just making them bigger or smaller. Okay, so here's a real life example again. When crumble was created, by the way, did you know that it was created in Utah, in Logan, Utah? And now they have stores in all 50 states and a couple countries, maybe. I don't know, but all 50 states, they're very big business now. But when they first started out, they didn't know if they were going to be very good. So they only made small batches of cookies. And let's say that first batch of cookies had 2 cups of sugar and 3 cups of flour. Could we write that as a ratio? Yeah. When we're comparing 2 things, we can write it as a ratio. 2 cups of sugar compared to 3 cups of flour. Okay, so here's my question for you. When they made it big, they needed lots of cookies. They needed to make big batches of cookie dough, but they also needed it to taste the same, right? Because they got big because their cookies were delicious, so they don't want to change the recipe at all. You just need to make a lot more of it. So what could the ratio of sugar to flour be in a larger amount? There's lots of different options, right? They could just double the recipe and get 4 to 6. Okay. They could triple the recipe and get 2 times 3 is 6, 3 times 3 is 9, right? But what about when they got like really, really popular? Could they maybe need to multiply it by 100? To get 100 times more cookies? Yeah, what would that be? That would be 200 to 300. So if they had a massive store and they needed to make cookies, they would mix in 200 cups of sugar, 300 cups of flour, mix it all up, and the cookies should taste the exact same as when they were making the 2 to 3 ratio. Okay, that is your equivalent ratio lesson. I want you to try a couple more on your own. This may or may not be on the test. So I have all these ratios here on top. What could I do to get some equivalent ratios? Well, I could times by 2, right? And get 2 to 6, or times by 3 and get 3 to 9, right? I could simplify. I could divide them both by 5 and get 1 to 2. Okay, so there's some things you could do. So this 3 to 6 is equivalent to, oh look, if I times by 3 times by 3, I will get 3 to 6 right there. And look, 3 to 9 goes right there. 6 to 10. Oh, look, if I times both of these by 2, I could get 6 to 10. Where do you think the 4 to 12 should go? If I take 1 to 3 and times them both by 4, that will give me 3 to 12, won't it? Or no, that will give me 4 to 12. So I could put 4 to 12 right there. 9 to 15, if I times both of these by 3, 3 times 3 is 9. 5 times 3 is 15. We got 9 to 15. Kind of cool, huh? Could you figure out the other ones? 5 to 15 would go right here because I could times both of those by 5. 2 to 4 will go right here because I could times 1 to 2 by 2 and get 2 to 4. And then 9 to 18 also goes right there. All right, so what I was doing is I was just timesing the top and the bottom by the exact same numbers, or dividing the top and the bottom by the exact same number to get those equivalent ratios. Last one, of the 21 people polled about the election for mayor, 12 said they plan to vote for the current mayor. What ratio is equivalent to 12 to 21? 12 to 21 seems pretty big. So, and these are all kind of smaller ratios. So I'm going to simplify and see what happens when I simplify 12 and 21. What common factor do 12 and 21 have? Well, if they were in a birthday cake, I could pull out a 3, couldn't I? So I'm going to divide both of these by 3, and that will give me 4 to 7. Woo! 4 to 7 is equivalent to 12 to 21. All right, my friends, I hope that gives you an idea of how to create equivalent ratios.